Are aliens trying to reach out? In the silent expanse of space, astronomers have captured signals unlike anything they've ever encountered before. This unsettling revelation has pierced the long-standing barrier of cosmic solitude. NASA has even issued warnings about an unseen, enigmatic object, sending unexplained radio transmissions toward Earth. These signals defy current scientific understanding, igniting a wave of speculation and fear worldwide. As both authorities and citizens attempt to decode this alien message, one burning question remains. Who or what is attempting to contact us from beyond the stars? And what could their motive be? Let's explore NASA's warning about mysterious objects transmitting unknown radio waves to our planet. Thanks to NASA's Kepler mission, astronomers have confirmed the existence of over 5,000 exoplanets within our small region of the Milky Way galaxy. Considering the vastness of space and time, it seems nearly impossible to believe Earth harbors the only intelligent life. Researchers at Australia's Parkes Observatory, while monitoring Proxima Centauri, detected a peculiar signal named BLC-1 during their decade-long search for extraterrestrial broadcasts among the nearest million stars. While unusual cosmic phenomena are not uncommon, this event stands out for its perplexing characteristics, prompting serious consideration of next steps. BLC-1 represents the most promising potential detection in the ongoing quest conducted by Breakthrough Listen for Extraterrestrial Intelligence, SETI. Since Frank Drake's Project Ozma in 1960, scientists have devoted over 60 years to scanning the sky for radio emissions that might reveal an intelligent artificial origin. Unlike naturally occurring radio waves, these intentional transmissions would resemble those produced by human technology. Such signals typically occupy a narrow portion of the radio spectrum and display a unique frequency shift suggesting movement toward or away from Earth, implying an origin from a celestial body, possibly a planet orbiting a nearby star. According to researcher Sheikh, only technology akin to ours could generate these precise patterns. Because Wi-Fi, satellite radio, GPS, and cell towers emit similar signals, isolating cosmic transmissions from Earth-based interference is extremely challenging. Astronomers have identified countless possible signals, many later traced back to pulsars, rapidly spinning remnants of dead stars that emit radio pulses, or other natural but previously unknown phenomena. Initially, scientists speculated that short, intense radio emissions known as fast radio bursts, FRBs, might be artificial in origin, though later research suggested otherwise. Even weaker periodic radio bursts puzzled astronomers until they found a surprising culprit, a microwave oven. Likely sources of interference for BLC-1 could include an undiscovered satellite, an airplane crossing the telescope's view, a nearby ground transmitter, or malfunctioning electronics from surrounding buildings or vehicles. The crucial task remains distinguishing between human-made interference and genuine technosignatures from space. Several signals over the years have resisted classification, most notably the renowned WOW signal. Ohio State University's Radio Observatory, or Big Ear, began scanning the skies for faint extraterrestrial signals in 1973. Then, one summer night in 1977, an unexpected reading changed everything. Jerry Ammon, an Ohio State professor volunteering with the Big Ear SETI program, was reviewing data from August 18, 1977, when he noticed something extraordinary. Instead of the normal sequence of single-digit readings, a sudden pattern of letters and numbers appeared, indicating a radio emission 30 times stronger than typical background noise. Excitedly, Ammon circled the sequence 6EQUJ5 in red ink and jotted down one spontaneous remark: "Wow!" Thus, the WOW signal was born, still regarded as humanity's closest brush with possible alien contact. Many amateur astronomers attribute its mysterious characteristics to an extraterrestrial source, yet its exact origin remains unresolved even decades later. Despite numerous follow-up attempts, the WOW signal has never been replicated. In SETI's early years during the 1960s, researchers limited their search to our solar system, considering interstellar travel technologically unfeasible. Given the immense distance between Earth and any potentially habitable world, practical exploration was seen as unattainable. Instead, scientists kept their focus on Earth-based detection. Their logic was simple. If intelligent life exists, it likely understands radio communication just as we do. Energy-efficient, long-distance signaling via radio waves would be the rational method to announce, "Hello, universe, we exist." The next question was where to listen. Cornell University physicists Philip Morrison and Giuseppe Cacconi proposed a best guess theory in the early 1960s. They suggested that an advanced civilization might select a universal frequency familiar to all scientific beings. Hydrogen, the universe's most abundant element, emits at a frequency of 1,420 MHz, a natural cosmic standard. SETI scientists therefore concluded that this would be the ideal frequency for any alien civilization to transmit a message across the stars. Using massive radio telescopes, astronomers began scanning the sky within this frequency range, focusing on one sky patch at a time before moving to another in their endless search. That's exactly what Jerry Emin and the Big Ear team were doing during the summer of 1977, targeting a section near the constellation Sagittarius. The WOW signal they recorded at 1,420.4556 MHz matched almost perfectly with hydrogen's emission frequency, precisely what SETI theorists predicted for an intentional communication. The signal shape also strengthened its case. Plotted over time, it showed a pattern consistent with something originating beyond Earth. Unlike natural cosmic sources, such as stars and galaxies, that produce a wide range of frequencies, the WOW signal was remarkably narrow-band, consistent with the technological transmitter. Its apparent source pointed toward the galactic center, home to a dense cluster of stars, an intelligent choice for interstellar communication. The WOW signal thus remains one of astronomy's most compelling mysteries. While some scholars believe it was the first real contact, skeptics insist it had a natural or earthly cause. In 2015, the Breakthrough Listen initiative launched a 10-year, $100 million search backed by investor Yuri Milner, further advancing SETI's mission. When scientists began observing Proxima Centauri in 2019 to study its powerful stellar flares, a student named Shane Smith from Hillsdale College analyzed the data and stumbled upon BLC-1. Even though the signal was faint, it displayed all the characteristics researchers look for. It was narrowband, frequency shifting, and vanished when the telescope turned away from Proxima. Despite extensive testing to eliminate false positives, BLC-1 passed every filter, reigniting debate over whether humanity had finally intercepted a message from another world. Over the next several days, 4 similar transmissions were detected, though some were later dismissed as radio interference. If by some extraordinary chance BLC-1 truly originated from the star system nearest to us, then, statistically, the Milky Way would have to be overflowing with communicating civilizations, says Seth Shostak from the SETI Institute. That would mean there are possibly more than 500 million intelligent societies within our own galaxy, a staggering concept. After this discovery, astronomers turned their instruments back toward Proxima Centauri, but no additional signals were found. In addition to keeping the Parkes telescope trained on Proxima, researchers are now working on new methods to determine the true origin of these mysterious transmissions. Could something or someone be reaching out to us? For decades, Earth has been receiving bizarre radio pulses, and scientists remain uncertain about their source, making the situation even more unsettling. New analyses show that these signals have been striking our planet since as far back as 1988, yet no one knows what cosmic object might be responsible. Bursts of radio energy with varying strengths have been observed at regular 22-minute intervals over the past 35 years, sometimes occurring only 5 minutes apart. Until this recent finding, scientists thought it was impossible for an object to emit such steady and powerful signals over that period. The latest paper, titled "A Long-Period Radio Transient Active for 3 Decades," explains that the object producing these signals is now designated as GPMJ 1839-10. Researchers learned through archived data that the signal has been consistently hitting Earth since 1988, despite the object being located about 15,000 light-years away. One plausible explanation could be pulsars, dense neutron stars that emit beams of radio waves because of their rapid rotation. When these beams sweep across Earth, they appear as short, brilliant bursts, much like the flash of a lighthouse. If a pulsar spins fast enough and has a strong magnetic field, our instruments can detect its radiation. However, pulsar emissions usually fade within a few months or years. This phenomenon, known as the death line, marks the point when the star's magnetic field weakens too much to sustain high-energy radiation. Yet this newly observed signal stands out for persisting for over 30 years. Another possibility is that it could be a magnetar, a type of neutron star that possesses an even stronger magnetic field than a pulsar, but rotates far more slowly. However, according to Natasha Hurley-Walker, a radio astronomer from Australia's International Centre for Radio Astronomy Research and the leading author on the study, this particular object rotates too slowly to emit radio waves at all. In other words, it seems to have crossed that death line. The existence of such an object defies what we know about both neutron stars and magnetars, which rank among the universe's most extreme celestial entities. Regardless of the cause, its mechanism is extraordinary. But what if our current cosmic silence ends abruptly when we finally confirm the existence of alien life? Would humanity celebrate or panic? If such a revelation ever became public, skeptics argue that governments would rush to conceal it, fearing the masses couldn't handle the truth. An even more alarming scenario is that communication attempts could expose our planet's exact coordinates to potentially hostile extraterrestrial forces, a concept that sounds straight out of science fiction, but remains a legitimate concern for some scientists. The question lingers: what would actually happen if SETI finally detected a verified extraterrestrial message among the relentless stream of earthly radio noise? Some argue that even entertaining this line of thought is an act of arrogance. After all, SETI astronomers have spent over half a century scanning the skies for such signals without success. If we haven't yet won the cosmic lottery, why worry about what comes next? Yet, like buying more tickets, every new observation and technological advancement improves our chances. Modern detection systems, fueled by exponential computational growth and improved sensitivity, have accelerated the search to unprecedented levels. At this rate, conclusive evidence of extraterrestrial life could potentially emerge within a few decades, unless it turns out alien civilizations are either remarkably elusive or non-existent. But if the day comes, what then? In the spring of 1960, astronomer Frank Drake conducted the first formal SETI experiment, whimsically named Project Ozma, after L. Frank Baum's fictional Queen of Oz. Few realized that during this pioneering effort, Drake actually detected something peculiar. While focusing his radio antenna on Epsilon Eridani, a nearby sun-like star, he picked up an intense rhythmic signal, an early and tantalizing hint that perhaps we were not alone after all. Astonished by how fast his search bore results, Drake found himself asking, "What do we do now?" The rhythmic bleeps emerging from his speakers turned out not to be signals from another world, but terrestrial interference. To continue the search, he expanded his instruments and refined his approach. Modern SETI detectors now monitor hundreds of millions of channels at once, whereas Project Ozma could only focus on one single frequency. Consequently, receiving signals is routine rather than remarkable. Every scan typically returns hundreds of them. Naturally, this doesn't cause much excitement. Instead of manually verifying whether a signal could represent alien intelligence or, like Drake's earlier result, was just human-made noise, scientists depend on advanced algorithms to analyze data. Any signal that makes it through this automated scrutiny is extremely rare. If such a case arises, researchers conduct additional checks to eliminate system errors, software faults, or even pranks. Once all internal tests are completed, they seek confirmation from another observatory. These thorough steps demonstrate that scientists take potential detection seriously, and rightly so. Yet, because verification takes time, early reports of intriguing signals may create confusion and disorder. SETI follows an open policy. There is no secrecy. So word of any discovery would likely spread rapidly through research blogs and social media before any official announcement could be made. Long before a press conference declares the finding of life beyond Earth, the news would already dominate global headlines. A genuine discovery would undeniably be historic. In 1996, when scientists announced that a Martian meteorite contained fossilized microorganisms, the public handled the revelation calmly. These microscopic structures, thinner than a strand 1/100th of the width of human hair, didn't attract much attention. After all, humanity's experience with technology spans only about a century, whereas any advanced species we detect would almost certainly outpace us scientifically and technologically. This is precisely what motivates SETI's continuing effort. Despite the unease the idea provokes, most people view it with optimism. A 2005 survey by the National Geographic Channel, the SETI Institute, and the University of Connecticut found that 72% of Americans would feel thrilled and hopeful upon confirmation of an alien signal, while 20% admitted they'd be apprehensive. Given that any such signal would likely come from hundreds of light years away, or practically safe distance, this reaction seems understandable. At least initially, all we would know is that the signal exists. Still, every telescope on Earth would immediately swing toward its source. Scientists would want to know if the signal came from a star, and if so, whether that star hosted planets. NASA might even revive its long-paused terrestrial planet finder project, reigniting the push to explore further. There's much we could learn promptly about where the signal originated. Within 1,000 light-years lie tens of millions of stars, each separated by mere angular differences in the sky. High-resolution instruments like the Jansky Very Large Array in New Mexico, which has a beam width of about 5 arcseconds at 1,420 megahertz, the main SETI frequency, could easily pinpoint the transmitter's exact star. Once located, we'd know where our potential neighbors reside. Beyond that, slight frequency shifts in each signal could reveal deeper details, as radio astronomers Jim Cordes and Woodruff Sullivan proposed 2 decades ago. These variations, caused by the Doppler effect and by the rotation or atmosphere of an alien planet, could, in theory, uncover its rotational period, orbital characteristics, size, satellite count, and even information about its magnetic field and atmosphere. Technically inclined experts would find that fascinating, but most of the public would be asking another question: what are they trying to tell us? That assumes, of course, that the signal carries a deliberate message. Perhaps the aliens prefer silence first, to test our response or gauge whether we're ready to communicate. If the signal does contain information, deciphering it could prove immensely difficult. To make themselves sensitive to extremely weak signals, astronomers use long observation times that effectively blur out rapid changes, similar to how long exposure photography erases fast flashes of light. As a result, any fast-moving or brief data in the message might be lost in the noise. Detecting a broadcast resembling a television transmission, for example, would demand an antenna about 10,000 times larger than today's average radio telescope, an undertaking requiring vast resources and effort. Yet scientists agree that after a confirmed detection, funding would no longer be an issue. While research accelerated, the world's population would face a new reality. Humankind would no longer be alone. We might not yet know what these beings are like or what knowledge they might share, only that they exist. That awareness alone could reshape how we see ourselves. After astronauts' first view of Earth as a fragile blue sphere inspired global unity decades ago, many believe a genuine alien signal could do the same on an even grander scale. How humanity ultimately reacts, however, remains uncertain. Some will feel awe, others discomfort, but a bona fide SETI discovery would leave permanent marks on civilization. The long-term consequences of such a momentous event would depend on whether we could interpret any content in the signal. Deciphering it might sound like a solvable puzzle, just a matter of patience and ingenuity. After all, humans eventually decoded ancient scripts like hieroglyphs and Linear B, once thought indecipherable. But the universe is far older than us, and the wisdom embedded in such a message might simply exceed the capacity of our limited minds. Even so, if we optimistically assumed we understood the transmission, its insights could range from physics and astronomy to cosmic biology, interstellar travel, and countless topics that seem like science fiction today. Gaining that knowledge overnight would trigger an intellectual revolution, altering the trajectory of our species and revealing paths we might not otherwise discover for millennia. Yet such enlightenment would also remind us of our insignificance. Compared to another civilization, human divisions would seem trivial. Some, like city pioneer Joel Tarter, believe this realization could foster unity and confidence that our own species might survive its turbulent technological adolescence. Others, such as sociologist Don Tarter from the University of Alabama in Huntsville, hold a more cautious view. He points out that following the space age, when images of Earth as a lone blue orb briefly inspired hope, humanity soon returned to conflict and fear. We're back to the usual battles and rivalries, he notes. And that leads to another dilemma. Should we respond if we discover where the aliens live? Could replying expose Earth to danger by broadcasting our precise location? While no one can predict whether extraterrestrials are peaceful or aggressive, the truth is that for nearly a century, humanity has been unintentionally transmitting, through radio, television, and radar, signals easily detectable by advanced civilizations. These invisible broadcasts already illuminate Earth's presence. A nearby civilization could even observe our planet's city lights using their own sun's gravitational lens. Any deliberate attempt to answer would merely confirm details they might already possess, speculating about the long-term consequences of a fork. Successful SETI mission is nearly impossible. One thing, however, is certain. If SETI achieves success, it will provide irrefutable proof that life exists elsewhere in the cosmos, alongside pulsars, nebulae, and countless planets. Though this revelation may not instantly unite humanity, it will shatter the illusion that we are unique or central to creation. From that day forward, humankind will know it is but one species among many, an ordinary voice in a vast cosmic chorus, and that truth, no matter how humbling, will undeniably shake the world. Thank you for watching another episode of Voyager. Before you go, be sure to click the video on your screen for more fascinating explorations of space and beyond.